bodies, which are very far. So, you try to decide, can you open the window, Jean? We will consider a far object in the chapel, no? Probably, a leaf there, or kanang Mother Perpetual Help. Or for the boys, probably, ang mga guwapa diha, no? Mga guwapa diha.
Yes.
Kanang far, jud far. And it should appear near. So, similarly, we will have our eyepiece and our objective. And our object shall be very far. Okay? So, your task is again to position the lenses so that what is far will seem to appear near. And more or less, if it's near, it should be a bit bigger. Not really big, but it's bigger po compared to that one that is far. Okay, so would you like to... So, muna inyong task, ha? And again, since these are two convex lenses, the objective should be of far focal length. Because, how can we get an image that is far if this is short focal length? It should be of far focal length. That's why it's thin. Yeah. Remember this, the thicker the lens, the shorter is the focal length. So the thinner it is, the longer also is the focal length. Now, we are going to construct two types, namely the astronomical and the Galilean. So para sa iyon, ayaw na nig-ikuan, muna ni para astronomical. This is for the Galilean. Okay? So the astronomical, I repeat, consists of two convex lenses. The eyepiece is of either short or moderate. I think it's moderate, but this one should be of far focal point. So how do we determine the focal length? Use the parallel ray again. Okay? And when you construct an astronomical, the hint that I can give you, the lenses are quite far from each other. But for the Galilean, it's quite like this. It's like that. So you try to decide on the adjustment. Ano po nga murag inline sila. Otherwise, mag-ana mo. Okay, ha? So, the one that is far should appear near. And since this is convex lenses, I think balik yung makita. No, okay. Otherwise, hindi pa balik mo dito. Now, if we construct, by the way, how do we tally our data in page 60? What's that, 70? 73. Okay, let's go to page 73. We are in the astronomical. So we need to know the focal lengths of both the objective and the eyepiece. What did we say earlier? We use the parallel ray, the flashing in the wall. So please use your meter stick. And then we install them onto the optical bench. Whatever is the distance between the two lenses is our measured L. CLM, that's the next quantity. But what is this computed L, which is LC? You just add the focal lengths of the two lenses. So, panangitan, 10 ni siya, niya 50. What is the sum? 60. And try to see if it coincides with your measure, which is 60. Okay, so how do we measure? Using the bench, that's the difference between the two lenses. I mean the length is between the two lenses. But the computed is just adding the focal lengths of the lenses. By then, we can compute for the magnification. Where is that? Look at equation 1. Consider the ratio of FO and FE. Okay? So, in terms of the focal length lang ta, para dali. Okay, we do the same with the Galilean. So, over here is the Galilean. But what's the difference between the astronomical and the Galilean? The objective is still of far focal length. So, you're still using a convex lens. But, what about the eyepiece? The eyepiece is now, instead of a convex, we shall replace it with a concave. Now, it's easy to determine because we need to determine again the focal lengths of the objective and the eyepiece. Since this one is convex, we use again the wall. Diba? The parallel ray. But this one, we cannot go away, we cannot use the parallel ray. So please use the contact method. You can use the box. Okay, so take this out and then pair it with a... Do not use this in the bench because this is a far focal point. You cannot get an image because the bench is quite short. So you can borrow either lens 1 or lens 2 of experiment 12. Okay, to determine the focal length. And then again, we need to do the adjusting so that you can get a clear image, more or less, that is far, it should appear near and quite bigger. And it should be claro, of course, really blurred the image ha. And then, after measuring the focal length of each, get the distance between them, which is LM. And for the computed L, it is this length, focal length plus this. Bear in mind, this is negative because it is concave. So, let's say, negative 30 ba ni, plus 50. Pila may difference?
20.
So, tanawag 20 ba ni. Okay? And then, you complete for the magnification using, again, equation 1 in terms of the ratio of the focal lengths. Okay? So, you may start.